Welcome to the Explainer. So, today we're going to dive into a software design pattern that, well, honestly, it kind of melts your brain the first time you read about it. But I promise you, once it clicks, it becomes this absolute secret weapon for writing incredibly clean, scalable code. We are talking about the bridge pattern. If you've ever found yourself just completely drowning in a sea of rigid, duplicated classes, you are absolutely going to want to stick around for this.
Now, if you've studied design patterns at all, you've probably stumbled across this exact quote from the classic Gang of Four textbook. The intent of the bridge pattern is to decouple an abstraction from its implementation so that the two can vary independently. Right. I want to completely validate whatever you're feeling right now, because honestly, that sounds like absolute gibberish at first glance, doesn't it? It feels so abstract and just totally disconnected from the real code we're actually writing every single day.
Okay, let's dive into this. We're going to completely strip away all that academic jargon and translate this super abstract concept into a concrete, highly relatable software architecture problem. By the end we wrap up this explainer, those textbook words are going to make total, practical sense. I guarantee it.
Here's our roadmap for today. We'll start by decoding the bridge pattern. Then we'll look at the Cartesian product problem, talk about composition over inheritance, compare views versus resources, and finally, look at the bridge in action. And to keep things grounded, we'll use a real-world example, building the UI for a Spotify-style media app.
All right, Section 1, decoding the bridge pattern and setting up the UI dilemma.
So imagine you're tasked with building a brand new screen for our media app. You've got different types of media, and you need to display them in a few different ways. Here's the basic setup. We have two different display views. There's a long-form view, think of a large, detailed layout with massive images and lots of text, and a short-form view, which is more like a compact little thumbnail. On the flip side, we have two different media resources we actually want to display, musical artists and books. So we need an app that can take an artist or a book and gracefully display it in either that long-form layout or the short-form layout.
Moving on to Section 2, the Cartesian product problem, or the danger of pure inheritance.
Now, what's really interesting about this is the trap most developers, myself included by the way, fall into first when dealing with this kind of requirement. We try to rely on pure inheritance. If we explicitly code every single combination of view and resource, we create this super rigid grid and our code instantly gets incredibly clunky. We end up writing a long-form artist resource class, a short-form artist resource class, a long-form book resource, and a short-form book resource. We've essentially just multiplied our two sets of concepts together.
Now, 4 classes doesn't sound like the end of the world, right? But watch what happens when we hit exponential growth. Imagine we add just 2 more resources to our app, let's say albums and authors. Our little 2x2 grid instantly explodes into a 4x2 grid. Suddenly, we're forced to write and maintain 8 separate, highly rigid classes. And what if you add another view type like a scrollable view? Boom, you're maintaining 12 classes, staring at a file literally named long-form scrollable audiobook resource and, seriously questioning your life choices.
This right here is what we call the Cartesian product problem. It leads to this massive exponential class explosion. But the true pain point? It's the duplicated logic. Think about it. If you discover a UI bug in how your long-form layout renders an image, you can't just fix it in one nice central place. Nope. You now have to hunt down that exact same layout code inside long-form artist resource, long-form book resource, long-form album resource, and so on. It is an absolute nightmare to maintain.
Which brings us to Section 3, composition over inheritance. This is where we build the bridge.
So how do we escape this maintenance nightmare? Well, we bring in the hero of our explainer, the bridge pattern. This pattern relies entirely on shifting our mindset away from inheritance and over to composition. Let's define composition real quick. Instead of forcing our classes to inherit everything they are from some rigid family tree at compile time, composition is all about extracting behavior into separate, reusable pieces. Think of it exactly like snapping building blocks together at runtime. We need to take the things that change independently, like our layouts and our media data, and separate them so we can just mix and match them on the fly.
And this brilliantly illustrates the massive difference in scalability. Just look at the math here. If we use pure inheritance with 4 views and 4 resources, we multiply them. 4 times 4 means we're writing 16 distinct classes. But if we switch to composition, if we separate the view concepts from the resource concepts, we just add them. 4 views plus 4 resources equals exactly 8 classes. We literally just saved ourselves from writing and maintaining half of our entire codebase. Talk about a game changer.
All right, Section 4, Views versus Resources, separating the independent from the specific.
Now that the math makes sense, we can finally decode that original super confusing Gang of Four textbook quote by applying it directly to our app analogy. We are going to separate the platform-independent stuff from the platform-specific stuff. Let's explicitly translate those terms. When the Gang of Four says abstraction, in our specific world, that is just the view. It's the platform-independent layout. And when they say implementation, well, that's just our specific media resource. It's the platform-specific data. The whole goal is that we want the view layout to vary completely independently of the resource data.
Let's break down the view's job. The view doesn't care at all if it's showing an artist, a book, or an album. It really doesn't. Its only job is to construct the structural layout. It has a show method to actually render things, and crucially, it inherently has a resource instance variable. It fully expects to be handed a building block of data, and it trusts that data block to follow a predictable, uniform interface.
On the flip side, what's the resource doing? Well, the resource basically acts as an adapter. It deals with all the highly specific, messy underlying data. For instance, an underlying artist object might have a bio property, while a book object might have cover text. Our resource class grabs that specific data and feeds it into the uniform interface that the view is expecting. It maps both of those wildly different properties to a single, standard method. Let's call it a snippet.
And finally, Section 5, the bridge in action, putting it all together. Okay, let's move to and see how this builds in a real technical breakdown. We're going to step through the code logic and see exactly how these two independent hierarchies, our views and our resources, actually interact across the bridge. Step 1, when we create a view, let's say a long-form view, we pass a specific resource into its constructor, like a book resource. Step 2, the view starts setting up its platform-independent layout, maybe putting an image box on the left and a text box on the right. And Step 3, when the view actually needs the text to fill that box, it delegates. It essentially crosses the bridge. It asks the resource, hey, give me your snippet. The view has no idea it's grabbing a book's cover text. It just knows it asked for a snippet, and it successfully got a string back.
Now, there is an incredibly interesting technical nuance here regarding the interface segregation principle. Let's say we snap our book resource into a short-form view, which, remember, is just a tiny thumbnail image. That short-form view simply doesn't even call the snippet method on the resource. And guess what? That's perfectly fine. We aren't breaking any interface rules here. The resource offers a full, uniform menu of data, but the simpler view just ignores what it doesn't need for its specific layout.
So the crucial point is this. Implementing the bridge pattern brings absolutely monumental benefits to your code. It prevents you from duplicating your layout logic across a dozen rigid classes. It entirely stops that Cartesian product class explosion dead in its tracks. And by strictly separating the platform-independent structures from the specific data implementations, you allow your codebase to scale so gracefully. You could add 10 new views and 10 new resources tomorrow, and they will all seamlessly snap together without breaking a sweat.
Now that you understand how to build this bridge, I want to leave you with a bit of a challenge. Look at your current projects. Look closely at the naming conventions of your classes. Where is a rigid, multiplied Cartesian product class explosion hiding in your codebase right now? And more importantly, how quickly can you refactor it using composition? Go snap some building blocks together. Thanks for joining me on this explainer, and I'll catch you next time.